First of all, do you notice that these ones, as far as our pattern goes, are either a 1 over x or a 1 over x squared graph? Or we even had somewhere an x over x squared. But if we were going to summarize this, the first group is when the degree was bigger in the numerator. The second group is when the degrees were same. And now the degree is bigger in the denominator. Denominator. Wow. The degree is bigger in the denominator. And it's characteristic when this is the case. Some of these have vertical asymptote, some of them don't, but the key characteristic is that there's always an asymptote at y equals 0. And we can use the same strategy that we used for group 2 to figure out that horizontal asymptote at y equals 0. And it goes like this. In group 2, we looked at what was the highest degree. And then we wrote that fraction out just with those highest degrees. We can do the same thing here. In the whole fraction, what's the highest degree? It's an x squared. If I just write the x squareds, I have one x squared on the bottom. How many x squareds do I have on the top? None. 0 x squareds on the top. And if you would do 0 x squared over x squared, you would get 0. Same thing here. What's the highest power? It's an x squared, the highest degree. On the bottom, I have a negative x squared. But on the top, I have no x squareds. And if I look, what happens when x gets really big in this case? You're going to get 0. Same thing on this one. I have an x squared on the bottom, but no x squareds on the top. And so I would get an asymptote at 0. And for the last two, here, highest power is an x squared, and I have no x squareds on the top. I have an x on top, but I have no x squareds on top. So I'm going to get 0. And finally, for the last one, same thing. No x squareds on top, x squared on the bottom. You're going to get 0. So you're always going to have y equals 0 as an asymptote. Other things, you could have a vertical asymptote if there's a non-permissible value. Is there a non-permissible value here? No, because can you see that x squared plus 2 is always positive? Here, if you factored this on the bottom, negative x and x, we're going to have to do 1 and 3. No, this will be minus 3 and minus 1. That'll give me plus 3 in the end, plus 3 and minus 1, plus 2. So you'll get x equals 3, and here x equals negative 1. So once you factor that, sure enough, there's two non-permissible values, and that's where you get your asymptotes in this case. Third one, you can see the non-permissible value is 0, so you have an asymptote at x equals 0. Same thing in this one. If you plug in 0, x is equal to 0. And finally, the last one, x squared plus 1 is never equal to 0. And so you don't have any vertical asymptotes. This last one feels a little bit weird because the graph actually crosses through our asymptote. Because horizontal asymptotes are not the same kind of thing that's happening with a vertical asymptote. A vertical asymptote is saying where you have a non-permissible value, so it can never equal it. Whereas a horizontal asymptote is more saying what happens when x gets really big positive numbers or really big negative numbers. It's not so concerned what happens in the middle. And in this case, right, this could be equal to 0. Because when can a fraction equal 0? When the numerator is equal to 0. Can 4x ever equal 0? Sure, when x is equal to 0. But as you go really, really big, it will approach 0. So you have a graph that goes through in this case. Okay, so that is group 3. That is the characteristics. So now if we did a super summary of this whole thing, the first thing you're going to do is look at the degrees in the numerator and the denominator. Right? And what did we notice? In group 1, it was bigger in the numerator. Group 2, they were the same. And group 3 was bigger in the denominator. That's the first thing you're going to do. Second thing you're going to factor and draw all of your asymptotes and holes. So sort of as an idea, you're going to first look at the degree. You're going to say, I know what kind of graph it is based on whether it's bigger in the numerator, same, or bigger in the denominator. And those kind of things will tell you stuff about your asymptotes. So you can draw a bunch of your asymptotes already. You may need to factor to draw some more asymptotes. You may need to factor to find out if a factor cancels, so you have a hole. And then we're going to sketch it after we have our asymptotes. And we're going to go through some of the strategies for sketching it tomorrow in 2.3.